When seeking guidance on electrical wiring, several resources can provide valuable assistance. One option is Michol's Pocket Pro, an app that offers access to electrical codes, calculations, diagrams, and videos. Another resource is Electrical Training Solutions, which offers online courses, DVDs, and books on electrical wiring. EC&M Electrical Construction and Maintenance is a website with articles, videos, and training resources on electrical topics. The National Electrical Code Handbook is a reference book that covers electrical codes and wiring practices. Lastly, NFPA 70, the National Electrical Code, is the official electrical code standard published by the National Fire Protection Association, or NFPA. To get started with electrical wiring, it is important to familiarize yourself with the electrical code by reading through the National Electrical Code, or NFPA 70, to understand the basic requirements for electrical installations. Secondly, it's crucial to understand the electrical theory by learning about basic electrical principles such as voltage, current, resistance, and circuits. Thirdly, determine your wiring needs by calculating the electrical load for your project and determine the appropriate wire size and type. Fourthly, plan your wiring layout by drawing a diagram of your electrical system, including the location of outlets, switches, and fixtures. Fifthly, install the wiring by following proper wiring techniques and adhere to the electrical code. Here are some helpful tips. Firstly, don't be afraid to ask for help from an electrician or experienced do-it-yourselfer. Secondly, practice on a small project before tackling a larger one. Thirdly, use a multimeter to test your wiring and ensure it's working properly. Fourthly, always turn off the power before working on electrical wiring. Remember that electrical work can be dangerous if not done properly. Before undertaking any electrical work, it's vital to understand the fundamentals of electrical theory. Voltage is the electrical potential difference between 2 points in a circuit and is measured in volts. Current is the flow of electrical charge and is measured in amps. Resistance is the opposition to the flow of current and is measured in ohms. Circuits are closed loops through which current flows, and they can be series circuits, where components are connected in a single path, or parallel circuits, where components are connected in multiple paths. Understanding these basic principles is crucial for designing and installing safe and effective electrical systems. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical installations. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is updated every 3 years to reflect changes in technology and best practices. It is essential for electricians and other electrical professionals to be familiar with the NEC to ensure that their work complies with safety regulations. When planning an electrical wiring project, it's important to accurately calculate the electrical load. This involves determining the amount of power that each electrical device or appliance will draw. The total load is the sum of all the individual loads. The electrical load is used to determine the appropriate wire size and overcurrent protection for the circuit. Undersized wires can overheat and cause a fire, while oversized overcurrent protection can allow too much current to flow and damage equipment. The NEC provides tables and guidelines for calculating electrical loads. Wire size is an important consideration in electrical wiring. The size of the wire determines its ampacity, which is the amount of current that it can safely carry. The NEC provides tables that specify the ampacity of different wire sizes based on their insulation type and installation conditions. It's important to choose the correct wire size to prevent overheating and potential fire hazards. The type of wire used in an electrical installation is also important. Common types of wire include THHN, THWN, and UF. THHN and THWN are typically used for indoor wiring in dry or wet locations, respectively. UF wire is designed for underground use. The NEC specifies the types of wire that are permitted for different applications. Grounding is a critical safety measure in electrical wiring. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip the overcurrent protection device and prevent electrical shock. The NEC requires that all electrical systems be properly grounded. Grounding electrodes, such as ground rods or metal water pipes, are used to connect the electrical system to the earth. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices interrupt the flow of current when it exceeds a safe level. The NEC specifies the appropriate overcurrent protection for different circuits based on the wire size and load. It's important to choose the correct overcurrent protection to prevent overheating and potential fire hazards. Electrical outlets, switches, and fixtures must be installed according to the NEC. Outlets must be properly grounded and located in accessible locations. Switches must be rated for the voltage and current of the circuit. Fixtures must be securely mounted and wired according to the manufacturer's instructions. The NEC provides detailed requirements for the installation of electrical equipment. Electrical boxes are used to enclose wiring connections and protect them from damage. The NEC specifies the types of electrical boxes that are permitted for different applications. Electrical boxes must be properly sized to accommodate the wiring and devices. They must also be securely mounted to prevent them from coming loose. Wiring methods refer to the way that electrical wires are installed and supported. Common wiring methods include conduit, cable, and surface raceway. Conduit is a rigid or flexible metal or plastic tube that protects wires from damage. Cable is a group of wires bundled together in a protective sheath. Surface raceway is a metal or plastic channel that is mounted on the surface of a wall or ceiling. The NEC specifies the types of wiring methods that are permitted for different applications. Electrical safety is paramount when working with electricity. Always turn off the power before working on electrical wiring. Use insulated tools and wear appropriate personal protective equipment, such as rubber gloves and safety glasses. Never work on electrical wiring in wet or damp conditions. If you are not comfortable working with electricity, hire a qualified electrician. Electrical inspections are typically required for new electrical installations and renovations. The purpose of an electrical inspection is to ensure that the work complies with the NEC and local electrical codes. Electrical inspectors check for proper wiring methods, grounding, overcurrent protection, and equipment installation. If the work passes inspection, the inspector will issue a certificate of compliance. If the work fails inspection, the inspector will provide a list of corrections that must be made. Troubleshooting electrical problems can be challenging. A multimeter is an essential tool for troubleshooting electrical circuits. A multimeter can be used to measure voltage, current, and resistance. It can also be used to check for continuity, which is a complete path for current to flow. When troubleshooting electrical problems, it's important to follow a systematic approach. Start by checking the power source and then work your way through the circuit, testing each component until you find the problem. Here are some common electrical problems. Firstly, a trip circuit breaker. This can be caused by an overload, a short circuit, or a ground fault. Secondly, a blown fuse. This is similar to a trip circuit breaker and can be caused by the same factors. Thirdly, a non-working outlet. This can be caused by a trip circuit breaker, a blown fuse, a loose wire, or a defective outlet. Fourthly, a flickering light. This can be caused by a loose wire, a defective switch, or a problem with the light fixture. Fifthly, an electrical shock. This is a serious safety hazard and should be addressed immediately. If you experience an electrical shock, turn off the power and seek medical attention. The NEC provides specific requirements for different types of electrical installations, such as residential, commercial, and industrial. Residential installations typically involve lower voltage and current levels than commercial or industrial installations. Commercial installations often involve more complex wiring systems and equipment. Industrial installations may involve high voltage and current levels and require specialized equipment and procedures. It's important to be familiar with the NEC requirements for the type of electrical installation you are working on. The NEC also addresses specific types of electrical equipment, such as motors, transformers, and generators. Motors are used to convert electrical energy into mechanical energy. Transformers are used to change voltage levels. Generators are used to convert mechanical energy into electrical energy. The NEC provides requirements for the installation and operation of these types of equipment. Renewable energy systems such as solar photovoltaic or PV systems and wind turbines are becoming increasingly popular. The NEC includes specific requirements for the installation of renewable energy systems. These requirements address issues such as grounding, overcurrent protection, and disconnects. It's important to follow the NEC requirements to ensure that renewable energy systems are installed safely and effectively. Energy efficiency is an important consideration in electrical wiring. The NEC includes requirements for energy-efficient lighting, appliances, and wiring methods. Energy-efficient lighting uses less electricity to produce the same amount of light. Energy-efficient appliances use less electricity to perform the same tasks. Energy-efficient wiring methods reduce energy losses in the electrical system. By following the NEC requirements for energy efficiency, you can save money on your electricity bill and reduce your carbon footprint. Smart home technology is becoming increasingly popular. Smart home devices can be controlled remotely using a smartphone or other device. The NEC includes requirements for the installation of smart home wiring systems. These requirements address issues such as network cabling, control systems, and security. It's important to follow the NEC requirements to ensure that smart home systems are installed safely and effectively. In summary, electrical wiring is a complex and potentially dangerous task. It's important to have a thorough understanding of electrical theory, the NEC, and safe wiring practices. If you are not comfortable working with electricity, hire a qualified electrician. Always prioritize safety and follow the NEC requirements to ensure that your electrical installations are safe and effective.